Hello, this is Dr. Hui Liu from San Jose, California, United States. My email is ibridgepy@gmail.com. IBridgePy is an easy-to-use Python platform to help traders to build algorithm trading robots. It can backtest and live trade with interactive brokers, Robinhood, and TD Ameritrade. You can download iBridgePy from www.ibridgepy.com. Please don't forget to subscribe to the channel because more tutorials are coming.
I'm going to talk about IBridgePy backtester, and right now backtester is much easier to use than the previous version. The goal of this tutorial is to demo how to backtest strategies use historical data from any data provider. The motto of this backtester is to supply data that backtester needs, which means there are many historical data you may not need for your specific strategy, so that you don't need to supply them, and it will save time and save cost of purchasing this historical data, because historical data, most of the time, historical data is not free. So in this tutorial, I'm going to talk about to start a backtest by switch to data provider name to local file. In our other tutorial, we have talked about use interactive brokers as the data provider. But this time, we will talk about use local file to load data from local file. So this time, we need to switch to local file. And then pick a start time, pick an end time of your backtesting. Then the critical step is to add a historical HistIngestionPlan with fileName. We will talk about this in more detail. Then we will talk about load historical data file from any local folders. You can specify the folder in IBridgePy backtester. So when you use historical data from other data providers, you may need to adjust data format a little bit. We will talk about what's the required data format in your file. After the demonstration, we will talk about pros and cons and how to improve in the next steps. More tutorials will be coming. And we will talk about other related tutorials to help you understand this demo. To the code and give you a real-time demo about backtesting in IBridgePy. So first, I would like to talk about the strategy we're going to backtest. This strategy is called close price reversion. And this strategy is very simple. The basic idea of this strategy is if yesterday's price is higher than today's close price, which means there is a price drop at the end of today's trading day before market close. If there is a price drop from yesterday to today before the market close, then we assume there is a price reversion, which means tomorrow's price will go up. Then at this moment, before the market close, we place an order to long the position, which means we want to buy. And in this strategy, we want to buy 100% of the portfolio. If today's price is higher than yesterday's price, which means there's a price jump, then we think it's time to sell off our portfolio. Because yesterday there's a price jump and we got benefit, then it's time to sell. This strategy is here. There are two basic functions. One is initialize. In this function, we define shared variables in IBridgePy. So we have a variable called context.security to define security, which is the ticker is SPY, which is ETF to track SP500 index. We use SPY as a demo. And there's a IBridgePy function called schedule function. This function is in IBridgePy is to schedule other functions to run at specific time. In this example, it takes 3 variables. The first one is called daily function actually, and this is the function name. We define daily function name here, which means we want to run this schedule to run this function at some time. And there is a date rule and a time rule. The date rule is what day you want to run this strategy, want to run this function. The day rule is every day, which means every trading day, because weekend we don't trade. And the time rule defines when in a day you want to execute this function. And we said we want 1 minute before market close. And this is the time rule. So which means this function will be triggered 1 minute before market close every trading day, which is 3:59 p.m. Eastern Time, because the US market closed at 4 p.m. And we assume the price at this moment will be very close to the real close price. And daily function is the function where the trading decisions are really made. So first, we print out the time when this function is triggered. So we use an IBridgePy function called getDateTime. And then we request historical data. Because we only need a daily bar and we only need yesterday's price, so we request historical data of SPY, and we want daily data. We want to go back 2 days. The close price is this. Yesterday's close price is this, and today's close price, even if the market is not closed, but we assume at this moment the price is very close to close price already. If close price today greater than yesterday, we want to sell. So we use an IBridgePy function called order target percentage. Otherwise, we long this position. And this is the strategy we are going to backtest in IBridgePy. To the code to give you a real-time demo. So first, I would like to start from our previous tutorial about the easiest setting of IBridgePy backtester. In the easiest backtester, what we need to set up is very simple. File name, account code, because we were using interactive brokers as the data provider, real-time data provider. So we use IB here, and then we pick a start time, end time. Then we click start. I won't do the real demo this time, but in this easy setting, whenever IBridgePy needs any historical data, it will retrieve the historical data from interactive brokers, because we specified we want the data provider name is interactive broker. The issue with the easiest setting is every time IBridgePy needs any historical data, it will go to interactive broker to retrieve historical data, but it really takes time, especially when you want to backtest a longer time period. Then we have an improvement. The improvement is we create a HistIngestionPlan. before the backtesting really started, which means we retrieve historical data from interactive broker as a batch. Batch means all together. In this example, we retrieve minute bar data, go back to 40 days in a batch, so which means get them together, load them into the local computer cache, and then use the historical data in local cache to speed up the backtesting process. And the real data provider is still interactive brokers, you can see here. That's the improvement. However, in this setup, we are still tied to data provider interactive brokers. What if you have other data providers? You don't want to use interactive brokers. And then that's this tutorial's topic. In this tutorial, let's switch to other topic is to load historical data from local file. Local file means IBridgePy will look for where the historical data in your local computer and then use that local computer, the file in local computer to do simulation. It means if you have any other third-party data provider, you can download historical data from that data provider and save the file to your local file. Save the data to your local file. And then use that local file supplied to backtester to do backtesting. And the motto is only supply the data that backtester really need. Think about the buy low, sell high strategy. The data we really need are two parts. The first one is daily bar data, because in strategy, we need the price of yesterday, so that we need daily historical data. The other part of data we really need is the minute bar data. The reason for that is when there is a transaction, IBridgePy backtester needs to know the transaction price at that moment to simulate the transaction. However, if we only have a daily bar data, there's no way to know what's the transaction price at 3:59 because our transaction happens at 3:59. So we need to provide minute bar data to tell IBridgePy data what's the price at 3:59 p.m. to simulate the backtesting. So in the setting, what you need to change is change the data provider name to local file, so that IBridgePy will look for local file. Then you need to create actually HistIngestionPlan is a reserved keyword in IBridgePy. It is used to store historical data injection plan that describes what historical data are needed during backtesting. And IBridgePy backtester will fetch this data before backtesting to speed up the whole backtesting process. As we mentioned, this one is not required, but if you do, it will make backtesting much faster. Also, HistIngestionPlan is an instance of HistIngestionPlan here. This is a Python concept of object-oriented programming. So after this line 29, we have an object of HistIngestionPlan. Then what we use is an add function, which is a function inside HistIngestionPlan, which is IBridgePy backtester function. This one is used to add individual historical plan. As I explained, I need to add two parts of historical data. One is minute bar to simulate the transaction price. The other one is to supply daily bar. because in our buy low, sell high strategy, we need historical data from yesterday. So I use a plan. Plan is IBridgePy backtester class. So we use plan to define what kind of historical data we want. It has 3 parameters. Security, which tells, okay, this file will be supplied to SPY, which is the strategy we are going to test. Bar size, it will set, it tells backtester, use this file to simulate minute bar. Then the third one is called file name. This is the real local file name that you are going to use. There's only the file name instead of the folder name. The default folder is IBridgePy input folder. So you can see I have this file there and there so that we can start backtesting. As a demo, I changed the backtesting time from 50 to 10 to just quickly show you the result. Okay, done. You can see overall the backtesting is very fast already. And let's come back to the data injection section to look what's happened. So first it tells ingested hist from this file. You can see it's from input folder and the file name. And then we can see the ingested hist, security is SPY, bar size is 1 minute. Then to verify we have loaded the correct data, you can see the first line of hist and the last line of the hist. So you can tell we have enough historical data to do the backtesting. Then the daily bar file, daily bar size is 1 day, and the first line of historical data loaded and the last line of historical data loaded, so that we know we have loaded the correct file into backtester. And then the backtesting started. You can see this is the file I'm testing. And then backtesting starts. As we can see, the daily function is triggered every day at 3:59, and the simulated transaction happens. You can see the price is provided by historical data there. To analyze the backtesting performance, IBridgePy has a tool in the tools folder, which is portfolio sharpratio.py. If we go to this file and use the functions that use latest backtesting balance log, the reason for that is the backtesting result will be saved in the folder of output, and there are 2 files. One is called balance log. In the balance log, it has 4 columns. Simulated date, simulated time, and this one is the portfolio balance, cash balance. This one happens every day. So which means every line means a simulated at the beginning of the simulated day, so that it gives you a daily balance of the simulated process. The other log is transaction log. In the transaction log, it records every transactions in your strategy. You can see bought, sold, number of shares, transaction price. To visualize the backtesting performance, let's use these two. Use latest backtest balance log, because you may have many balance logs if you have done many simulations, but we would just want to use the very latest balance log to see the performance. So we run this one. Okay, it gives you the daily balance plot, so you can see, but we only have 10 days. Also, the annualized Sharpe ratio is printed out there, so you can compare with other strategies if you want. Let's talk about what if your historical data does not lives in IBridgePy input folder. For example, I literally put my files, historical data, in the output folder. You can imagine you can put anywhere you want in your local computer, and the file is specified by a full path, full file path. For example, this one is output. What you can do is to specify, let's comment out line 29, comment in line 30. Here's the injection plan can take an input variable called default folder name. So the default one is input. However, this time I want to load my historical data from output folder instead of input folder. So what I'm doing is to specify I want the current the project folder, which is my local Yellowstone IBridgePy folder. It's the name of my local folder. And I want it goes into it and look for output folder. And then the file name will be same file name. And let's run it again. We can verify IBridgePy tester. Oh, not this one. I want to switch to the local file. So backtesting started and finished completely. Let's go to data injection section to see right now the hist is ingested from output folder instead of input folder. So which means you can specify the folder by using a default folder name in HistIngestionPlan. So after this demo, we would like to take a look about input file format because it matters. Let's take a look about, let's go to the input folder and take a look the epoch, this one. Let's open daily file as a demo. So this one is relatively shorter. And the format of this file is, it has a header. The first line is the header of your data columns. It should have a comma, empty one, and a comma, which means the first one is actually the first one is the epoch second. Epochs means count the second to the origin, one of the original time, which is 1970 January 1st, and how many seconds elapsed from there. So this is the, actually this is an integer, but it represents a time. Then there are 5 columns: close, high, low, open, volume. The sequence does not matter, but all of these column names should be lowercase. And each line is a historical data line. And the earliest line go to the first, the latest line go to the go to the bottom. So this is the format we are using right now. And if we switch to minute line, the format is same, but this one is much longer because this one is the minute bar data. So same format, everything same. Earliest line first, latest line bottom. However, we noticed that convert a date time into epoch second is not that straightforward, so that IBridgePy is able to consume if here is just a datetime string there. For example, let's open this one. You can see this time we have the first column is the name of it is called timestamp, and the timestamp is a string with date and time with time zone. This column is we convert the epoch column into an index column, but it's not needed for your local testing. As long as you have first column is a time, and then open hello, close volume, then you're good to go. This time, let's switch to input folder, and we switch to the other file. And you can see this time the file index is date time. As we opened, the index is date time zone already. So that we want to use this file to backtesting. And let's run it. So backtester started as we expected, and this time you can see the input folder index of date time. So we loaded the correct file. And also let's verify the data we ingested. So first line, last line, minute bar, daily bar here, first line here, last line here, and the file is the index of date time. So that you can, as long as the time is a reasonable format, IBridgePy backtester will try best to recognize the backtesting time index. The demo about backtester using historical data from local file. It's time to talk about the pros and cons of supply historical data from local file. So we talk about the pros. Pros means advantage. So think about you can use historical data from any data providers by download historical data from third-party data provider and save it to local file, and then use that for backtesting. The next prompt is you can backtest any contracts as long as you have historical data from any data providers, data sources. That's very powerful. And also, if you want to speed up the backtester, you just end only with limited historical data. You can supply only what the backtester really needs and make the backtester a successful result. However, we need to talk about the cons. Cons means disadvantage of the current setting. You have observed backtesting still slow, especially when you want to backtest, go back to a long time period. For example, back to 10 years. The backtesting will be still slow. So to solve backtesting still slow, we have another feature in IBridgePy backtester is to use custom spot times, which means you just supply the spot simulation time or backtesting time and tell the backtester that only test this backtesting times, ignore other backtestings. We will have other tutorial to cover this topic later. IBridgePy backtester, there are a few other YouTube tutorials you may think of. For example, we have a tutorial to use machine learning skills to build buy low, sell high strategy. Also, we have a detailed explanation about how to implement this strategy in IBridgePy. To analyze portfolio of backtesting performance, we talked about how to use Sharpe ratio, how to calculate Sharpe ratio of backtesting result. You can refer to this tutorial. If you want the easiest setting to start with backtester, you can refer to backtest without his injection. This is the easiest backtester you can use. And you just need start time, end time, and then click start. Backtester will start. However, if you want to speed up backtesting by ingesting historical data before testing, you can refer to this tutorial. Also, when you supply historical data to backtester, you may need to convert historical data format. You can refer to this tutorial.
Thank you very much. For any questions, please send an email to ibridgepy@gmail.com. If you need any help on coding, please check out our well-known Run a Coder service. More tutorials are coming. Please don't forget to subscribe. IBridgePy is an easy-to-use Python platform to backtest and live trading. Thank you very much.